Hi guys, today we're going to be doing integration by parts. I'll be solving all of the problems that you see on the board. I'll have a number up at the top of the screen that kind of shows which problem I'm currently working on, so if you're looking for a specific problem, you should be able to scroll ahead and pretty quickly find the content that you're looking to get to. But essentially with by parts, what you're trying to do is to use the formula that you see in red on the board and pick u and dv in such a way that it makes the problem simpler than when you started, and as you repeat this process you wind up whittling down that integral into something that's manageable. So let's get started. For problem 1, our basic approach is going to be to try and whittle away this power of x. When you have a power of x, by parts can sometimes be used to reduce the power until it eventually drops off, and so that'll be our approach for number 1. For the first problem, we have the integral of x squared times e to the 3x dx. Okay, so in this case, we're going to pick u is equal to x squared because when we take the derivative, we get something that's a little simpler. It's 2x. Whereas when we're going to set dv to e to the 3x dx, which gives us v is equal to e to the 3x over 3. So this integral, which I'll call I, is going to be by the by parts formula uv minus the integral of v du. In this case, we have u equals x squared times e to the 3x over 3 minus the integral of v e to the 3x over 3 and then du, which would just be 2x dx. Put that dx there, that's missing. Okay, great. We've moved forward in the problem. We still kind of have an issue because we have minus 2/3 integral of x e to the 3x dx. We still have this thing to deal with right here, okay? So this guy here. So let's apply by parts again and hope that it's going to help us out. So again, we're going to take u equals x so that du is equal to dx. And we'll pick dv as e to the 3x dx, and we're going to pick, we know the integral of e to the 3x is e to the 3x over 3, and so we can now plug it in, so we get the I, our integral, is x squared over 3, e to the 3x minus 2/3, and then uv, which is x e to the 3x over 3, minus the integral of e to the 3x over 3 times dx, since that's our du. Okay, so let's write this out. So that's going to give us x squared e to the 3x over 3 minus 2 over 9 x e to the 3x plus 2 over 9 integral e to the 3x dx. This integral we've been doing the whole time, so our solution will just be x squared e to the 3x over 3 minus 2 over 9 x e to the 3x plus 2 over 9 times e to the 3x over 3 plus c. Factor out the e to the 3x over 27, giving us 9x squared minus 6x plus 2, all plus c. So that's essentially the answer. Now for the next problem. Okay, so for this problem, we're going to have to choose which one to integrate and which one to take the derivative of. And because the integral of ln x is x ln x minus x, very, very unlikely that that's going to help us. But the derivative of ln x is just 1 over x dx. So it could be that that's probably the way to go. So let's let u equal ln x, and so du is going to be dx over x, and then dv is going to be x dx, and so v is going to be x squared over 2. Therefore, we know that I is going to be uv minus the integral of v du by the formula, which is going to be x squared over 2 times ln of x minus the integral of x squared over 2 times du, which is dx over x. And luckily for us, we have some canceling that goes on here. And so the next line would just be x squared over 2 times ln of x minus the integral of x over 2 dx, which is just x squared over 2 times ln of x minus, so you take the 1/2 out here, and so that would give us 1/2 times x squared over 2, and all that plus c, and so therefore we can have x squared over 4, 2 ln of x minus 1 plus c. That's how you do that one. Number 3 is a kind of special one, and we're going to wind up using the fact that I keep writing out I is equal to, and you'll see why in a second. In this one, it really doesn't matter which one we decide to take, the derivative or the integral. What matters is that we stay consistent as we do additional steps. So because e of the x is unbelievably simple, I'm going to choose to integrate that one, because that's usually what you do. You choose the path of least resistance. So u equals of sine of x du cosine x dx. And so dv is going to be e to the x dx, v is e to the x, and I is uv minus the integral of v du by the by parts formula. And so that's going to be sine x times e to the x minus the integral of v e to the x times cosine of x dx. Before we had sine x e to the x, now we have cosine x e to the x. That seems like the same problem to me. Let's do one more step of by parts. So in this case, we're going to, again, choose the same direction, not to undo the work we did. We'll let u equal to, u equal to cosine of x. Du is going to be equal to negative sine of x. dv, e to the x dx, and v is equal to e to the x. Our I is equal to sine x times e to the x minus, now instead of that integral, we're going to put that uv minus the integral of v du, so that's e to the x cosine of x minus the integral of e to the x times minus sine of x dx. Now, if I distribute out the negatives and just simplify things a bit, something should become apparent. Minus e to the x cosine of x plus minus, because there's 1, 2, 3 minuses, so it stays negative, minus the integral of e to the x sine x dx. Well, wait a minute, this is exactly what we started off with. That's I. So I can send that to the other side, the equation, and say 2I is equal to e to the x sine x minus e to the x cosine of x. Or in other words, I is equal to e to the x sine x minus cosine of x all over 2 plus c. And so that's how you do that one. Alright, so for this problem, we're going to need to split this up into something that we can take the derivative of and something that we can take the integral of. And it's not obvious, but if we write this out as secant squared of x times secant of x dx, then we can recognize that this is actually the derivative of tan. And this is a derivative that we can take easily. So knowing that, let u is equal to secant x. So du is going to be secant x tan x dx. And then we're going to let dv be equal to secant squared x dx. And so v will be tan. And the whole point of choosing them this way is just so that when we apply the formula, we get something a little bit easier to work with. So this gives us that the integral is going to be uv minus the integral of v du by the by parts formula. So that'll give us tan x times so tan x times secant of x, okay, minus the integral of tan x times secant x times tan of x dx. Okay, we can write this out as tan x times secant x minus the integral of tan squared of x times secant x dx. Now here, one thing we can do is we can use an identity to simplify this out. Now the one that I always remember is sine squared x plus cosine squared of x is equal to 1. Now if we divide everything by cosine squared of x, we wind up getting that tan squared of x plus 1 is equal to secant squared of x, and therefore secant squared of x minus 1 is equal to tan squared of x. Now this is the one that we're going to use to substitute for this tan. Use different color, so our I is going to be equal to tan of x secant x from before minus the integral. Now instead of tan squared of x, I'm going to put secant squared of x minus 1 times secant of x dx. Okay, has this made our lives any easier? Well, we'll see. Let's multiply things out. Secant of x minus the integral of secant cubed x dx, and we can separate these, plus the integral of secant x dx. Okay, well this is actually just, pick another color, so that's actually just our I. So that we can take this minus I and send it over here. And so that gives us 2I is equal to tan x secant x minus plus the integral of secant x dx. And secant is one of the basic functions that you should memorize the integral for. And so the final answer will be tan x secant x plus ln of secant x plus tan of x plus c, and all that is divided by 2. So that is one way to solve this problem. Okay, on to the next one. Okay, so for number 5, we have the integral of the inverse tan function. So the first thing I'll do is say that this is the integral of arctan of 4x dx. Now this is just so there's no confusion by some people that might think that it's 1 divided by tan of x because of the negative exponent. So let's just write it like that. And we do have to know the derivative of the inverse trig functions. In this case, we only have one function, so we can't split anything out. So one of them is going to be just one, the number 1 is going to be a constant, and the other one will be this arctan of 4x. We're going to set u equals to arctan of 4x. So u is equal to arctan of 4x, and so du is going to be equal to, normally it would be 1 over 1 plus x squared, but in this case it's 1 plus 4x all squared, but then we have to multiply by 4 for the chain rule, and so it becomes 4 over 1 plus this 4x squared, and at the same time dv is just 1 dx, and so v is x. Okay, and so I is going to be uv minus the integral of v du, which is just arctan of 4x times x minus the integral of x times du, 4 over 1 plus, and I'll just write that as 16x squared dx, which would be a dx here. Okay, so now we're essentially done with this one, but we still have some work to do left with this one. This just looks like a simple substitution integral where I would let u equals 1 plus 16x squared. Now it's not the same u, we're just doing a substitution now, and we're saying that du is going to be 32x dx, which means that dx can be substituted by du divided by 32x. Okay, so that means that we can write our integral I being equal to, so arctan of 4x times x minus, we have this thing, 4x over 1 plus 1 16x squared dx. Okay. Instead of dx, we have this thing. So that's going to replace dx, du divided by 32x. Now, this is going to let us cancel this x here, and the 4 can cancel with the 32, giving us 1/8. And then this thing here is just u. I is equal to arctan of 4x times x minus 1/8, the integral of du over u. So the integral of 1 over u is ln of absolute value. So we get minus 1 over 8 times ln of absolute value of u, which is equal to arctan of 4x times x minus 1 over 8 times the ln of, and then it's 1 plus 16x squared. That's always going to be positive, so we can get rid of the absolute value and plug that in, and that gives us our answer. Okay, on the next, second to last problem. Okay, so for this problem, we're going to want to take the derivative of the x part, because that is going to simplify our life. And we do have to know what the integral of 2 to the x is. And so, and that's something you should actually memorize, that integral of a to the x dx is equal to a to the x divided by ln of a plus c. Okay, so that's, we need to know that. It's one of the ones you have to memorize. It's one of the trickier ones. In this case, a is 2. Okay, so we're going to pick our u. U is going to be equal x. Du is equal to dx. And then dv is going to be 2 to the x dx. And so v is going to be 2 to the x divided by ln of 2. So our integral I is going to be equal to uv minus the integral of v du, which is equal to x times 2 to the x divided by ln of 2 minus the integral of 2 to the x over ln of 2 times dx. Okay, and we can factor, we can bring out the x to the x over ln 2 minus 1 over ln 2 integral of 2 to the x dx, but we know what that is, so that's just going to be equal to x times 2 to the x over ln of 2 minus 1 over ln 2 times 2 to the x over ln of 2, all that plus c. And so suppose we could simplify this a little. We could pull out a 2 to the x over ln 2, I suppose. 2 to the x over ln of 2 would give us x minus 1 over ln of 2 plus c. I don't know. It's a little nicer. Okay, last problem. Okay, so for this problem, we have, let's let u equals to ln x squared. Du is going to be 2 times ln x times 1 over x. dv is just dx, and so v is equal to x. And so our integral is going to be uv minus the integral of v du. U is ln x squared times x minus the integral. V is x times du is 2 ln x times 1 over x dx. Dx over here. Okay, great. So some things look like they're canceling, so that's gone, that's gone. Okay, so that's just ln of x squared times x minus the integral of, we'll pull up the 2, ln x dx. And since that's a basic function, it's an integral that you could do by parts, and the way that you do it by parts is by letting u equals ln x and dv equals dx and just doing another step. But since it is a simple function and one that you should memorize, I'm just going to state the answer times x minus 2 times x ln x minus x, all that plus c. So that would be the answer. I hope that this was helpful, and if it was, please subscribe and like the video, leave a comment if you have any questions or any specific problems that you need help with. Post a comment, and I'll see what I can do.